Happy New Year. So I hope 2025 turns out to be really great towards your career and you reach the great heights in your coding journey. You gain the bestest of the bestest rating you have ever imagined. My best wishes. With that note, let's begin with today's question, which is Leetcode question number 689, maximum sum of three non-overlapping subarrays. In this question, we are given an array nums and an integer k, and we have to find three non-overlapping subarrays which have length k and fetch the maximum sum. We have to return the indices for these three subarrays, and the indices should be smallest possible with the maximum sum. Okay, let's take the first example. We are given 1 comma 2, 2 comma 6 and 7 comma 5. The sum is maximum possible and the indices are minimum possible. Similarly here, right, we have k is equal to 2, so the length will be exactly 2. Although I can pick 2 comma 1, 1 comma 2 and 2 comma 1 with which gives us the maximum possible sum, but the indices are not lexicographically smallest, right? So to find that, what I can do is I can simply pick 1 comma 2, 1 comma 2 and 1 comma 2, right? So the indices will be 0, 2 and 4. Okay, so how can I do this question? Okay, one approach that comes to my mind is dynamic programming. Okay, which will be basically two-dimensional dynamic programming. So for that, what I will do is till any index, let's say till here, I will find the maximum value. Let's first focus on finding the maximum value, right? We will figure out the index later. Let's first discuss the maximum value. So to find the maximum value of three subarrays, I will build the answer with one subarray and then two and then three, right? So till here, if I want to find the answer for two subarrays, I have two choices. Either I will not take this element in the second subarray, or I will take it. Okay, so so dpi of 2. Okay, this basically means the maximum value possible for two indices. Yes, so maximum value possible for two subarrays of length k. Okay, that will equal to that will equal to this sum. Okay, this sum, so it will be 3 plus dp of I minus k, which is 2 in this example, minus k of with one subarray, right? Because we want only one subarray here, right? Because we have already chosen this. Or I can not pick this element at all, so the answer can also be dp of I minus 1 of 2. Okay, and I will find the maximum of this. As simple as that. Same case goes for dp of I of 3. Let's say I want to find for three subarrays till this index, right? What I will do is maximum of dp I minus 1 comma the sum for this 1 2, so it will 3 plus dp of I minus k, which is 2 in this case obviously, and for 2, right? So we will get the answer. We will do this for all the values, and then in the end we will get the maximum possible sum for three subarrays. Okay, okay, fine, but we are not supposed to find that. We have to find the indices for each, right? Now how can I find the indices? One thing that I can do is with each value I can also store the corresponding index for that. Let me explain. Like if if here I find this value to be maximum, okay, so the value for this will be the in this index I minus k, okay. Okay, great. But if this is maximum, the index for the second sub array will be the one found from this dp, which means that here we have to store value and index. We have to maximize this value, maximize, and we have to minimize this value, minimize. This is what we are gonna do. So let's go with the implementation and see how can we tackle this problem. Okay, let's try an approach. Integer n is equal to nums. You can also code along if you want. Okay, I will also discuss what I'm thinking as I do the programming. We have found the nums. Okay, now for and let's initialize all the dp states with -1. Okay, cool. So here we also need to begin with some base cases, right? So the base cases will be dp of I of 0 will be 0. Why? Because 0 means we are picking 0 subarrays. What does that mean? Which means that we are not picking any element at all, so the sum will be 0. But also we have to keep in account the indexes. So instead of int we will use pair, right? uh, let's initialize it with -1. Should not be a problem. Okay, so we have to initialize this with 0 comma 0. Why 0 comma 0? Because we have to minimize the indexes also, right? So it's correct, 0 comma 0. Now I can begin with the implementation of dp. Okay, let's try. Is equal to 0 I also. First of all, dp of I comma 3 is only valid when we have reached an index which is more than or equal to a length which can accommodate three subarrays, right? Which means that I length till I should be able to take three or more subarrays. um, let me take an example here, right? We have this example. If I am at this index, I cannot consider dp of I of 3 because till this index I cannot accommodate three subarrays. The least index that can be used is this. Why? Because here I can accommodate 3. Similarly for 2 also, and for 1 also. Okay, great. Also we have to keep track of prefix sum to find the sum of k elements. So let's make a prefix summary also. mm, I think we have to. Okay, Yep, we are done. We have made this. Okay, great. Okay, now let's try to write our dp states. Dp of I comma 3 is equal to maximum of dp of I minus 1 3. Okay, dp of, okay, prefix, I will explain what I'm doing. Prefix of I minus prefix of I minus k if I am here, right? So okay, great. Okay, great. Dot first. Hmm. So here, as you can see, if I am at this index, what I have done is first I have found the sum of this using prefix. Okay, then for the two sub array part, I have used this. I have fetched the value from here dp I minus k of 2 dot first, and then gotten the index also. Okay. Also, one more thing, that we have to minimize the index. Okay, but I am using max here. So in pair, what happens is, let's say I have one pair. Let's say a is equal to 1 comma 7. Okay, now if I do a is equal to max of a, okay, let's write code instead. It will be more clear here. Let's say a is a pair which is having values 1 comma 6. Okay, if I do a, if I do this, a is equal to max of a comma 4 comma 2. Okay, so here a will become 4 comma 2. So in the case of pair, what happens is, first the value of first is checked here. Okay, like from 1 and 4, 4 is bigger, so a will be assigned 4 comma 2. But if I am using, if I am comparing, if I'm using here 1, right, and 1 comma 8 here, so a will become 1 comma 8, because 1 is equal. So the next value, which is 6 comma 8, they will be compared, and and as a result, this will be stored inside a. So this can happen here also, right? Let's say the value for new is has come to be equal with the previous. Okay, so here we are getting a bigger index, let's say. So that bigger index will be stored. That's why what we need to do is, we have to put a minus here. Yeah, we have to put a minus here, and like this, minus I, minus of I minus k, right? Because for I comma 3, the index will be minus I minus k. We are having I minus k plus 1. Okay, this. Okay, this is how we are going to do. Same case for 2, and same case for 1. Here 1, here also, and here it will be 0. Cool. Here it will be 1. Let's try to debug it again. I will be maximum of I minus 1 3, and pair prefix of I minus k. Okay, this is correct. dp I minus k of 2 dot first. and the index will be I minus k plus 1. Okay, and if I'm here I minus k, which will be 7 plus 1, which it will become 5. Okay, seems correct to me. Hmm. Okay, correct. Now we have to check the in check this, right? If greater than 3 into k, which means that if index till I can accommodate three sub arrays here, right? If I is like here, okay, if it can accommodate three sub arrays, so it can 1 2 3, yeah. So if I is greater than equal to 3 into k, I'll do this. Hmm. Yep, we have done this. Okay. Also we have to do some. Okay, this is done. Okay, great. And where else? Okay, here also we should put some index checking. Okay, so I minus 1 is greater than equal to 0. Okay, I think we have done. Okay, now what I have done here. Okay, let's discuss that. First, I have done this, right? Which is, I think, pretty basic. Okay, है ना, this is the concept of prefix sum. What I have done is, let's understand it through this example one. Okay, like I want to find the sum of this. So what I will do is find the sum of this, right, and minus the sum of this. But if the sub arrays are like I want to find the sum of 1 and 2. So what I will do is I will find the sum of this minus sum of this. Now this becomes minus 1, so it will automatically be 0. That that's what I have done here. I minus k is greater than equal to 0, which means that I can do I minus k. If not, it will be automatically 0. So this is correct. And this is also correct. I mean, I, I have placed this just for the sake of checking the index, but I think it's not really needed, so I can remove it. Okay, we are good, because here I have all yeah, I have already checked, right? So it's not really needed, as k is at least 1. Great. Here also, I is at least 2. I is at least 2, so okay. Mm-mm-mm. Okay, we are, I think, done. Now let's find the indices. Okay, let's first print them. dp of n minus 1 3. Okay, dot first, and let's see if our DP implementation is correct, and return some arbitrary value. Oh, shit. It should be ideally correct. Let's see. And the answer will be a wrong answer, but we are more focused on this. Oh, this is pair, right? So, oh my god. This is correct. Yeah. For each index, this 0 will be 0 comma 0. Okay. Oh my god. This will be. This should be correct. Let's see. Oh, yeah. I can just initialize it with minus infinity comma minus infinity. Mm, yep, we are good. There are some silly mistakes that humans often do, but it should be okay. Oh my god. It should be typecasting issue. Buffer overflow. Okay. Oh, oh my god. I just did some blunder. Here it will be n. I just swapped the dimensions over here by mistake. Sorry, sorry. Now this is correct. Okay. DPI and 3. Okay, correct. N comma 4. Hmm. There is some overflow which should be taken care of. I don't know what is. Let let assert here. Maybe this is giving me some issue. Let's see. Uh, okay, which means okay, this is getting breaked. This is getting broken. Let's see why. If I is 0 and k is 1. Okay, that's why. Because if I is 0 and k is 1, this is getting satisfied, right? This is getting satisfied. So we have to find I minus k is greater than equal to 0. Elsewhere it's correct. Let's try. Yep, we are done. And let's see what index I'm getting, right? So the answer is 23. Okay, 7, 8, 9, 10, 11, 12, 12, 18, 19, 20, 23, and the index is 5. 0, 1, 2, 3, 4, 5. So in index is 5, which is correct. Yep. Index is supposed to be negative because we want the minimum index possible, right? So the index for 3 is deep index index for 3 is, now index for 2 will be dp of index 3 minus 1, 3 minus 1, because let's say for index 3 we get this, right, for 2, for fetching the index for 2 stop array part, we want from that index minus 1, right, we got this index. Now I want index minus 1 till 0. We want the index for that. So index 3 minus 1 comma 2 comma second, and put, and let's put a minus here also. Same case for index 1, index 2 minus 1 and 1 dot second, and let's sort these whether we don't need index 1, index 2, index 3. Let's see. Okay, we are getting one index wrong. I think, I don't know why, but let's try to figure out why. Mm-mm-mm. It is 0 here, which is correct. I mean, this is also correct. Do I need to do it 0? No. Mm, okay, we're getting one index wrong. Okay, let's see why is this happening. Mm, this is correct. Prefix I, it is also correct. dp of I3 is equal to max of this I minus 1 3. Okay, and this is also, this is okay, plus dp of I minus 1 0. We don't need this because this is always 0. My I minus k plus 1, which is correct. Okay. Mm. Next one is coming to be 1 for this. I don't know why. Okay. Perhaps it's coming because of this. If I remove this case, I'm getting accepted. Okay, let's investigate why. Okay, so I'm doing I minus k greater than equal to 0, which means that I'm ignoring the first index, right? Because if k is 1, I can be at least 1. So I'm ignoring I is equal to 0 case, which can also be for one sub array, right? So I'm ignoring that. So if I remove this all together, I'm good to go. I right. So this is always okay. We have to do this. This is correct. I k plus 1. Right. I think we are good to go. This should be correct. Let's submit it and hope for the best. we got accepted. Now let's summarize this approach all together. Okay, we have this, right? First of all, we have maintained a DP, okay, which is like this. Hmm. Okay, like this. Okay, this is for one. This is for one sub array. This is for two sub arrays. This is for three sub array in each, right? And this was zero sub arrays. This will always give 0 comma 0 all over. And for one, we will store here we will store here maximum value of sum and its index. We are going to store that, right? Now for this too, what I will use is, either I will pick any value at I, which will then come, we have to compute this, then we have to compute this. Okay, but if I don't want to choose that value at index I, uh, I will just simply use the previous one, like this. And we will do the same for three subarrays, and then we fetch the indices and just simply return the vector. This is how we are going to do this. Let's discuss the time complexity. Time complexity seems like it's simple big O of n, right? Big O of n here, as you can see, it's big O of n here, it's big O of n here, right? This is constant time complexity, so the time complexity is constant. And speaking of space complexity, that's also linear, because this 4 is constant, this n is like length of nums. Okay, so the space complexity is linear. So time complexity big of n, space complexity big of n. Let's analyze it from here also. Yep, we got the linear complexity, right? So this was our solution. I hope you like the approach that I used, and let me know in the comments if you get any doubts, or any part that was not clear to you. We can discuss that. Okay, and I guess thank you, and see you with the next one. Bye.